I'd like to introduce Mick McGrath, who's the Director of DevOps here at Bitovi. Docker containers are ubiquitous in the world of the cloud, and having your applications and microservices containerized is a great first step towards effortless scalability. So in this talk, Mick is going to walk us through how to Dockerize the DoneJS Place My Order app.
Thank you, Chasen. Okay, so we have built our front-end web application, possibly a server behind it. Now what? What do we do with it then? So ideally, we would deploy that thing somewhere, right? One of the best ways to do that these days in the world of cloud computing and scalability and things like that is with Docker containers. So Docker containers are essentially like they contain all of the dependencies that you would need. So you can kind of think about it as a little operating system in a box, and you can take that and it's only the things that your app needs to run, and you can deploy them on all sorts of different things like Kubernetes. I'm sure you've probably heard of. It's a container orchestration engine. Amazon has ECS, which is Elastic Container Service. And then there's a whole slew of other ones. But again, the idea is to take your applications and break them into small bits, like we call them microservices. So you'd have one for the front end, you'd have one for the back end, you'd have one for the database, and so on. And then that way, each individual component can scale independently from the other ones. You don't have cross-mingling of dependencies from front end and back end and that kind of thing. And so I'm going to walk through how to take an example app. We're going to use the DoneJS Place My Order application. I wonder, I haven't tried if this is up and running. Hopefully it is. Yeah, cool. Okay, so anyway, there's a guide for this, so you can follow along how to actually build the Place My Order app. And then once that's done, we can come over and Dockerize it so that it's ready to deploy into Cloudland. There is a PR up for doing this in Place My Order, so you can take a look at that. The branch is Introduce Docker. And I am just going to run through the Docker MD file, which kind of outlines how to do this, and then do live demo, because running with scissors is the way to do things, I guess. Okay, so if you want to Dockerize your application, the only prerequisite you need is Docker. And you need to know how to write Docker files, and so I'll walk through how to do that. So the Place My Order app is comprised of a front end and back end. Normally, you would want each microservice in its own separate repo, and each repo would have its own Docker file, and thereby creating its own Docker containers. In this example, I'm doing 2-in-1. I'm doing the front end and the back end in the same repo, but they will still create separate Docker containers, and we'll walk through what that looks like. Just to take a look at the package JSON, just so that you know how the app is run, there is a npm start script which runs done serve, and this serves the front end, and there is an npm API which runs Place My Order API, which actually does live in a separate repo. It's as a dependency for this one, but we're going to package it up in this one. All right, so that's how you run the front end and the back end, and that's just about all we need to wrap that in Docker. So in order to wrap this up, we're going to create two separate Docker files, and they are called, the typical naming of Docker files is capital D Docker file. And in there you have instructions for how the Docker container will be built, or how the Docker image will be built, and how the Docker container will be executed. So in this case, we're going to use a Docker file to build the front end. And the front end, we want to run Node. There are all sorts of containers. If you look at like Docker Hub, for example, you can get Python, PHP, all sorts of different base images. This is just saying I want my starting point, my starting operating system, to have Node and all of its dependencies installed. And so with that, we can say, here is where our app is going to live by specifying the work directory. We want to copy everything from from where we run the Docker build from. So we're going to copy everything from the current working directory into the working directory inside the container, which we have just defined as this user source app. Once all the files are in the container, we get all of our dependencies installed. npm install, we build it, DoneJS build. We make sure that when the container is running, we expose a port called 8080. And then whenever the container is started, we start it in this fashion. There are ways to override this, but by default, you can specify whenever you do Docker run, or whenever a container orchestrator executes this container, it will use DoneJS develop-docker to get started. Develop-docker is just saying done-serve --develop. It's giving a proxy. This is a done serve option here, so you can look at the done serve, but essentially it's saying all the requests we want to go to this URL, and this URL is place-my-order-api:7070. Keep that in mind because I'll show where that value is defined in the Docker world here in a moment. Cool, so now that's really it. So now we have this Docker file, and once it's built, we will have an image that is node-based. It contains our app, all of its dependencies, and the ability to expose the port and run the app on that port. Cool, and then we do a similar thing for the Docker API. Again, we're running node. We want to put the app in the user source app directory. Keep in mind, these are different images. So this code, assuming this would be like in some other repository or something like that, it's its own environment. It does not have anything to do with the front end. It just happens to be the same repo now, so it's going to be the same code, but they're completely separate environments. Copy all the files in there, install all your dependencies and stuff, and then on the startup of this one, we're going to just say DoneJS API. So the Dockerfile API will be built with Node, all of its dependencies, exposing port 7070, and whenever it starts up, it will do DoneJS API. Okay, great. So now we have pretty much everything we need to build the Docker container. And if you look in that branch, there's a scripts Docker, there is a build script, and the build script is going to say, all right, well, we want to Docker build. For the API, we want to specify that file, dockerfile-API. We tag it, and this will be a local tag called DoneJS/place-my-order-API, and dot is using the working directory from where the Docker build script was executed. And ideally, for us, this will be the root of Place My Order. And then we do a similar thing for the front end of the application. With that, I will go ahead and switch over here. So this is, git clone, Place My Order, check out the introduce Docker. Branch in Place My Order. And I have these Docker, or the scripts-docker, and there's a build script in there. Right, so the build script is what we're going to run, which is this one here. And the build script will create a couple of containers for us. So this is going to go pretty quick. If you do this for the first time, it will not go this quick, and you'll have a lot more output. This is the from scratch build. It has to actually go through and do all the npm install for both of those containers and set everything up. But I've already run it once, and so now it's cached, and I didn't change anything since the last time I built it. So it's whenever you change something, I don't know fully the criteria that tells Docker that it should actually rebuild the stuff versus use the cache stuff. Maybe it's based on the file timestamps or something. I don't know. Might be worth knowing and looking into, but anyway, I didn't change anything, so it didn't have to rebuild. Cool, so now we have a couple of containers. They are built. There's another one listed in here, dockerfile-ci. I'm not going to go into that really, but the concept is that you can use a another Docker container to run the tests. So we want our environment to be Node. We put everything we want it to go, install the dependencies, and then you should be able to run your tests inside of a Docker container. And then that's a really great way if your continuous integration server, use Jenkins, Travis, whatever it happens to be, can run Docker containers. Then you can create this Docker container and really just run your tests anywhere that Docker works, anything that has the Docker binding. So that's really nice. Cool. So now we built it. We've got the two images built, and now we want to turn the images into containers. Basically, we want to run the images, which are containers. So to do that, we have run. So let me look at the run script and walk through that a bit. So the run script is pretty straightforward. It creates a network that we're calling Place My Order. So the network in Docker allows both of these containers to know how to talk to each other. And this works on, regardless of platform, as long as you're running Docker, you can create like this internal network and connect your containers up to that internal network. And then you have like your own IPs and ports and things like that. One caveat is that they are still the ports are still exposed onto the host, which is a caveat and a good thing. It's good because then you can access the app, which I will show in a minute, but it's also a little bit tricky because if you have two separate networks and you have containers on separate networks that actually need the same port, you can't do that because you'll create one with 8080 and then you try to create another one with 8080 in a separate network, but it's still the host's network port 8080 is taken, so it'll fail. But that's okay, really, because what you can do is you can define different ports that are exposed on the host. So whenever you run Docker, the left is the port on the host, and the right is the port in the container. So you can kind of, anytime I hit the host port here, it'll convert it to the containers port there. So anyway, so there's the network. So in order to run these containers, we create the network. We say Docker run. We define our ports. Again, host container. We say we're going to attach this to the network Place My Order that we created a moment ago. We're going to name it. So we're going to name this container. This will come in handy in just a minute. -D is like daemon mode or behind the scenes mode. And this is the image that we created during the build step for the API. We're going to do the same thing for the front end piece. So for the back end, we've named this place-my-order-API. There's port 7070. You will probably remember that is exactly what we proxied here. So inside of that network, we can access other containers based on the name provided to that container. So we named that one Place My Order API with the port 7070. So from within that container, we can now access this other, the API container. Yeah, so then this will start up the containers. So let's do that. Let's say run. All right, so we're creating the network, running the PMO API, running PMO. So we can look at the running containers using Docker PS. We have a couple of containers running, when they were created, what commands they were used to start up, how long they've been up, what ports are exposed, etc. So now we have Place My Order and Place My Order API. And at this point, we have a running container with the port exposed on 8080. We can go to our browser and say host 8080 and wait until it loads. So now we have Place My Order running with the front end and the back end in Docker on our local machine. Another note here, we can say Docker logs, and we can specify the name of a running container if we want to say watch what happens when these are just the logs that are output by that service, that microservice. So if we reload this here, I guess it's not outputting. Maybe there's let's see if we can move this over. I guess it doesn't output anything. Anyway, it's outputting whatever the app outputs, but maybe the version I'm running. We can check the other one too. So there's the same, do the same thing. We can do it with the API. See there. I guess again, it's not like real-time outputting, but these are the logs output from each of those microservices. Cool. So now we want to, we've got it up and running, and then we tinker around with it, and we want to maybe turn it off. So turning it off can get a little tricky sometimes, but there is a script in here to walk us through it. So stopping this, we want to stop the container. Then we want to remove the container so that this name is released, so that we can start it up again. Essentially, there are other ways to do all of this, but this is just a pretty clean, straightforward way to do it. Do the same for the front end, and then we want to remove. And so now if we stop that, it will shut everything down, remove everything, and clean up for us. Yeah, and so from here, now we can, now we have our applications. They are ready to hand off to your ops guy or girl or team and say, here, we have some containers, or we have a way to build containers, and then they need to be published into a registry like Amazon's Elastic Container Registry or Docker Hub or something like that, so that they can then be pulled onto some container orchestrator like Kubernetes. I'll go through that in subsequent meetups for what comes next. Now we have our way to build containers. How do we, where do we go from here? So this I'm thinking will be a series going forward, but at least now you have some insight into how to prep your microservices or applications for cloud deployments. So yeah, that's it. It's me. What questions do we have?
Why not use Docker Compose?
Just like for this example, there were 2 little services that I wanted to create. Docker Compose is good for orchestrating a lot of different components. It's definitely worth doing if we have more microservices than just this 1 or 2, but just for the sake of simplicity, maybe we'll do a follow-up on Docker Compose. I think that would be good. It also provides some really good facilities for developing local with Docker, which is a little bit different than what we've done here, because you have to rebuild it and restart it, stop it and restart it, all that sort of stuff. Whereas Docker Compose provides a pretty good framework for you to just start it up in development mode. You have your local volumes sort of connected inside of a container, so you can make changes real time and not have to rebuild everything. So it's definitely a good way to go, especially for local development. This was just a simple, a simple way to go about it. So I think that'd be great for a follow-up, some subsequent meetup.
What about a follow-up with volumes and stuff like that?
Yeah, both, either one. So actually, one of the things that I'm working on right now is working through good, local Docker practices and getting that all written out and stuff. And so Docker Compose is one of those options. The other one is, using volumes in the containers and stuff like that as sort of a straight up script like this. Docker Compose is just there's some additional configuration and initial complexity in order to get that set up, whereas this is you're using a couple of Docker commands in a simple script. So there's a little bit of a trade-off there. If you're in a big team, Docker Compose is probably a better way to go. If you just have 1 or 2 microservices and it's just you and you have a pretty small team, then it may or may not be worth going the Docker Compose route. So yeah, lots of options there. I think they're just trade-offs.
And I have to plug, Nils has done a presentation at a previous meetup on using Docker Compose for local development. So there will be a link in the description. If you're watching this on YouTube, there will be a link in the description. I'll put a link in the chat too for people who are actually here live.